All right, we're going to look at finding dxdy now instead of dy dx. So far we've been finding y prime or dy dx, and that's because we're thinking of y as a function of x. So x is the independent variable and y depends on x. We can switch that around and regard y as the independent variable, and then find the rate of change of x with respect to y. When we do that, we call the derivative x prime or dxdy. So when we do this, the derivative of y is 1. The derivative of x, I forgot to write this in here, derivative of x is x prime or dx dy. Okay, so basically we're just swapping the roles of x and y here. So this says find dx dy given this. All right, the derivative of x cubed is going to be 3x squared dx dy plus 3y squared. And on the other side over here, we've got 6xy. Now, I'm going to break this up like this. I'm going to think of 6x as my first, and I'm going to think of y as my second function. If you want to leave the 6 out front as a constant and then treat x as your first and y as your second, that works fine too. But I'm going to do it like this. That way my first is 6x. Derivative of the second is just 1 plus second times derivative of the first is going to be 6 times x prime or dx dy. Now I've got to solve for this by getting both of these guys on the same side. So I'm going to move this one over here and this over there. So I get 3x squared dx dy minus 6y dx dy equals 6x minus 3y squared. So I get dx dy is 6x minus 3y squared over 3x squared minus 6y. And notice everything here is a multiple of 3, so I'm just going to divide everything by 3 and get 2x minus y squared over 3x squared minus 6y. But wait, x squared minus 2y.